Yesterday, when you guys were collecting data, you had four different cases to choose from. You had speed up, move away, slow down, move away, speed up, move towards, slow down, move towards. Okay, and so I just want to go through and make sure that you guys got some pretty good data when you were doing that. And so this is the first case. This is where the cart starts close, right? Speeds up because this line gets steeper and then stops here at the end. And the velocity time graph reflects that. It started at rest, it speeds up, and then all of a sudden it stopped because it got to the end and we caught it. And the acceleration time graph reflects that as well. Now I was looking at some of the things that got sketched, and I know there's a bunch of these big spikes in here, but we're not really interested in those, right? That's when the cart's stopping or starting or whatever's going on. We're interested in these portions where the cart's actually traveling on the incline. Okay, so I've got those all highlighted here with my time intervals, and if I just double tap inside there, the graphical analysis program will go ahead and zoom to that selection, which makes it a heck of a lot easier to actually sketch your graph. So if I come over to the lab and I want to sketch these graphs over here, I can do that, right? So now I've got my position time graph. It starts down here and gets steeper. My velocity time graph starts down here and slopes up. My acceleration time graph was positive line right above the axis. Okay, which we should know already. Speeding up, moving away means it's got to start close, get further away. Speeding up means it starts close to zero velocity and it's got to get faster, so it's got to move away from the axis, and since it's moving away, it's getting positive. And acceleration, well, if my velocity is getting more positive, my acceleration is positive. Okay, so we can actually sketch in the rest of these cases without collecting data. The cart is slowing down, moving away from the detector. Well, moving away tells me I had to start close and far, but slow down means it had to start steep and get less steep. Velocity, that means it has to all be positive because it's moving away, but it had to start fast and get less fast. Well, that means my velocity is getting less positive or more negative, however you want to look at it. So that means my acceleration graph has to be down here. C, the cart is speeding up, moving towards the detector. Well, that means it had to start far away, it had to get closer, and speeding up means it had to start slow, so fairly flat, and get faster, so steeper. Well, my velocity time graph means if it's starting slow, it's got to be at 0. It's speeding up, so it's got to get further away, but it's moving in a negative direction, so my velocity time graph has to look like this. Well, what about my acceleration time graph? The velocity is actually decreasing here, right? It's becoming more negative, so the acceleration is down here. And finally, D, the cart is slowing down, moving towards the detector. Well, if it's moving towards, it had to start far away, ends up closer. Slowing down means it had to start fast, so steep and flatter. Okay, that was a bad curve, but we're going with it. Okay, velocity, if it's slowing down, it doesn't start at 0. It has to start away from 0, and if it's moving towards the detector, it's got to be down here at negative. Okay, and get slower, so it's got to head towards positive. That means my acceleration, yeah, the velocity is all negative, but it's becoming less negative. That means my acceleration is positive, so it's up here. Okay, so when this thing asks you down at the bottom which cases produced a positive acceleration, well, it was cases A and D. Okay, they're the ones that had acceleration time graphs that were above the t-axis, and negative acceleration were cases B and C, and that's because acceleration doesn't show speed, it doesn't show position. All acceleration tells you is whether your velocity is becoming more positive or more negative. If it's becoming more positive, then the acceleration is positive. If it's becoming more negative, the acceleration is negative. The other way you could look at that is say if the acceleration is less negative, or the velocity is getting less negative, then the acceleration is positive, right? And if the acceleration or the velocity is becoming less positive, then the acceleration is negative. Okay? And that's what these cases all show. So let's look at that one more time. Okay, this velocity time graph is becoming more positive, so the acceleration is positive. This velocity time graph is becoming less positive, so the acceleration is negative. This acceleration, or this velocity time graph, is becoming more negative, so the acceleration is negative, and this velocity time graph is becoming less negative, so the acceleration is positive. It's kind of weird, but it makes sense when you think about it. Okay, we're just graphing the slope. Keep that in mind. Alright, so this sheet is close to being the end of the lab. It says homework there at the top because it really is something you can do without data collection. Okay, so an object moving along the positive x-axis has the acceleration time graph shown. How would the object move to produce this graph if it was moving away from the origin? Well, if it's moving away and its velocity is becoming more positive, that's what this positive acceleration means, then it needs to speed up, right? Speed up. How would the object move to produce this graph if it was moving towards the origin? Well, now if it's moving towards the origin, its velocity is negative, but it has to be getting less negative because the acceleration is positive, and so that would mean it has to slow down. Okay? On the axes below, sketch the velocity time graphs that go with the above acceleration time graph. Well, if I look at this acceleration time graph, it's a positive acceleration, and so for the first case, I know if I'm moving away, I got to have positive velocity, and I just said speed up, and this isn't going to be arithmetically correct, but the shape is right. Okay, the velocity time graph should look like that. How does that change if we're moving the other direction? Well, remember, to go the other direction on a velocity time graph, we have to be below the axis, but we said we had to slow down, so that means you've got to start down here and go up like that. Okay, you'll notice the velocity time graphs look exactly the same as far as their slope goes. It's just a matter of where they're starting. Okay, it's because acceleration doesn't tell me direction, it doesn't tell me speed, it just tells me is my velocity becoming more positive or less positive.